Exercise 238 is talking about a drug called isoniazid, and that is used to treat tuberculosis and multiple sclerosis. What they want us to do is to identify each lone pair and say whether it's localized or delocalized. And then they want us to justify our answer. Okay, well, let's just concern ourselves with this specific structure. In this specific structure, as drawn, we've got lone pairs on each of the nitrogens, so here, here, and here. And this nitrogen only has one lone pair because the H2 there, that's like 2 bonds to hydrogen. So it has 6 electrons around it, and so you need that lone pair. Okay, so one at a time. Well, the first thing you'll notice is that the lone pair on this nitrogen is very similar. This nitrogen at the left is very similar to the one we just saw for nicotine. That lone pair is localized, as we discussed a second ago, because, in the previous video, because the pi bond on that nitrogen is already using the py orbital that you would need in order to have that resonance. The py orbital that is parallel with the p orbitals in the pi bond, that's already being used by the pi bond, which means that there's only the px orbital, which would be like that, and you notice that doesn't line up parallel with any of these p orbitals, so it wouldn't let the electrons in the lone pair spread out, or the pz orbital, which has the same problem. So, in other words, the py orbital that this lone pair would need in order to form those pi bonds with the double bond pi bonds, that's already being taken up, and so this exists in a different orbital, in an sp2 orbital that's pointing out in space. And so that is localized. And for a slightly more in-depth discussion of that, you can see the video for 237 and also the video for 236D. Okay, so then we have this lone pair here, and that lone pair is allylic. If you go one atom over, you're at an atom in a double bond. And so because of that, this lone pair is delocalized. It spreads out over multiple atomic locations. Ultimately, it's going to be a sort of, if you have this bond, that lone pair will be flying between all 3 of those atoms. So it's delocalized. It's not on one atomic location. Now, this third lone pair, for this specific structure, this third lone pair also is not involved in any resonance patterns for this specific structure, as drawn. It's not allylic to any pi bond, and it's not allylic to any pi bond, and also it's not next to a positive charge. So I would be okay with you saying that that was localized, because in the structure as drawn, it's not involved in any resonance structures. If, however, you noticed that when you draw the resonance structure that you get from the first allylic lone pair, like if this lone pair goes to form a pi bond and those electrons go up, you would get this structure that I'm drawing down here. Another resonance structure. And in this resonance structure, these lone pairs are allylic. And so technically, those are able to exist in a pi bond, or a p orbital, that's parallel to the p orbitals here, and that's parallel to the p orbital in that oxygen, so that all these electrons just spread out over these bonds. So technically, that lone pair on the nitrogen would be delocalized in that case, because here it's allylic. Lone pair, so delocalized. So either one I would accept. Technically the bottom one is the correct one, but you don't have to draw out every single resonance structure. That adds a new layer of time and complication to the problem. So what you can do is you can just look at the structure they give you. If you see resonance in that specific structure, then it's delocalized. And if you don't see resonance in that specific structure, don't pull your hair out spending 20 minutes drawing every single resonance structure. You can if you don't see the resonance pattern in that structure, you can say that it's localized. But in general, it's good to be on the watch for things like this. It's because it'll make a molecule you may be interested in, whether it's a medication or anything, behavioral